fine and safe at your homes. Welcome to your SST class. So we have already finished with lesson 4 of civics, that is democratic government. We have learned the features of democratic government, and then the last one, the conflict, that was new concept in that chapter, and the importance of equality and justice. So today we are here with geography lesson number 3 with motions of the earth. So if we talk of lesson number 2 of geography, we have learned about the latitudes and the longitudes, that is parallel lines, lines of parallels, and the lines of meridian. We have also studied about international date line. Then we have studied about the standard time. So in this chapter we will be dealing with the new things. We will be studying two main things: rotation of the earth. So let's see what we will be doing. Number 1, rotation of the earth. Then we will be studying the revolution of the earth. So you will come to know the difference between these two words. What is revolution of the earth and what is rotation of the earth. So we will be studying also about Aryabhatta. You might have heard his name, Aryabhatta. And we will also be studying about Nicholas Copernicus. So he proved that earth not only moves around its own axis, but then it also moves around the sun, and this is also known as the rotation and earth depending upon the movement of the earth. So these two persons, I will be giving you a brief detail, and then we will be moving on to the main topics that are there in this chapter: rotation and revolution of the earth. Under it we will be studying circle of illumination. What is it? Circle of illumination. We will be dealing with that. Then we will be dealing with aphelion and perihelion. So these are the two terms that we will be dealing with. What is aphelion and what is perihelion. Apart from that, we will also study the solstices, the summer solstice, the winter solstice, that is the changing season. So that we will be taking up in the next video. For today, we will be discussing these three main terms. So I hope you are all ready to learn new things. So let's go.
Heliocentrism is the scientific model that first placed the Sun at the center of the Solar System and put the planets, including Earth, in its orbit. Historically, heliocentrism is opposed to geocentrism, which placed the Earth at the center. Aristarchus of Samos already proposed a heliocentric model in the 3rd century BC. In the 16th century, Nicolaus Copernicus de Revolutionibus presented a full discussion of a heliocentric model of the universe in much the same way as Ptolemy had presented his geocentric model in the 2nd century. This
The principles of Aryabhat's astronomy are collectively called the Odayaka system. In some of his later creations, it is said that Earth revolves around the Sun, and they also believe that the orbit of the Earth is not circular but elliptical. Aryabhat established that the Earth is constantly moving on its axis, and here are the reasons that the position of the stars in the sky varies. Aryabhat found the exact time of the revolution of the Earth. Aryabhat said the Earth rotates on its axis not in exactly 24 hours, but it rotates in 23 hours, 56 minutes and 1 second. Thus, We have 365 days, 6 hours, 12 minutes and 30 seconds in our first year. Aryabhat was the one who pronounced that the moon has no light of its own. It is visible because it mirrors the light of the sun.
As you know that the Earth has two types of motions, namely rotation and revolution. Rotation is the movement of the Earth on its axis. The movement of the Earth around the Sun in a fixed path or orbit is called revolution. The axis of the Earth, which is an imaginary line, makes an angle of 66.5 degrees with its orbital plane. The plane formed by the orbit is known as the orbital plane. The Earth receives light from the Sun. Due to the spherical shape of the Earth, only half of it gets light from the Sun at a time. The portion facing the Sun experiences day, while the other half away from the Sun experiences night. The circle that divides the day from night on the globe is called the circle of illumination. This circle does not coincide with the axis. The Earth takes about 24 hours to complete one rotation around its axis. The period of rotation is known as the Earth day. This is the daily motion of the Earth. What would happen if the Earth did not rotate? The portion of the Earth facing the Sun would always experience day, thus bringing continuous warmth to the region. The other half would remain in darkness and be freezing cold all the time. Life would not have been possible in such extreme conditions.
Of any orbit of a celestial body about the Sun is the point where the body comes closest to the Sun. It is the opposite of aphelion, which is the point in the orbit where the celestial body is farthest from the Sun. Etymology. The words perihelion and aphelion were coined by Johannes Kepler to describe the orbital motion of the planets. The words are formed from the prefixes peri Greek, peri near, and apo Greek, apo away from, affixed to the Greek word for the Sun. Helios, perihelion and aphelion are sometimes incorrectly used for the orbits of objects about bodies other than the Sun. The correct terms are: for orbits around the Earth, perigee and apogee; for orbits around a star, periastron and apastron; for orbits around any center of mass, periapsis or pericenter and apoapsis or apocenter. The ellipse has two focus points, and the Sun is at one of these focus points for the elliptical orbits of its satellites. Hence, an orbiting body has a closest and a farthest point from its parent object, that is, a perihelion and an aphelion. Each extreme is known as an apsis. Orbital eccentricity. Earth is about 147.1 million kilometers (91.4 million miles) from the Sun at perihelion around January 3, in contrast to about 152.1 million kilometers (94.5 million miles) at aphelion around July 4. A difference of about 5.0 million kilometers (3.1 million miles). These dates change over time due to precession and other orbital factors, which follow cyclical patterns known as Milankovitch cycles. For a table of these dates for various years, see apsis. Because of the increased distance at aphelion, only 93.55% of the solar radiation from the Sun falls on a given area of land as does at perihelion. However, this fluctuation does not account for the seasons, as it is summer in the northern hemisphere when it is winter in the southern hemisphere and vice versa. Instead, seasons result from the tilt of Earth's axis, which is 23.4 degrees away from perpendicular to the plane of Earth's orbit around the Sun. Winter falls on the hemisphere where sunlight strikes least directly, and summer falls where sunlight strikes most directly, regardless of the Earth's distance from the Sun. In the northern hemisphere, summer occurs at the same time as aphelion. Despite this, there are larger land masses in the northern hemisphere, which are easier to heat than the seas. Consequently, summers are 2.3 degrees Celsius (4 degrees Fahrenheit) warmer in the northern hemisphere than in the southern hemisphere under similar conditions. See also:
of Earth, rotation and revolution. Now we know we have Earth, right? And Earth has an axis which goes from North Pole unto the South Pole, right? Now the movement of the Earth, the movement of Earth around its axis is known as rotation. So when the Earth moves around its axis, it is known as rotation. Okay? So the movement is not around anything else but around the axis of the Earth. This is what is the axis which passes from the North and South Pole, right? As against this, if I talk about the revolution, we know that we have Sun, okay, and then we have Earth. Now the Earth moves around the Sun around a fixed path, right? So let's say this is the Sun, this is the Earth. In addition to rotating around its own axis, the Earth also revolves around the Sun. It follows this fixed path, and you know what this fixed path is called. It is called Earth's orbit, right? So the movement of the Earth around the Sun on this fixed path, which is called the orbit, is known as revolution, right? So the two types of motions are rotation and revolution. Rotation happens when the Earth moves around its own axis, right? Revolution happens when the Earth moves around a fixed path, okay, around the Sun. That is what is revolution. Now, we know that the Earth has an axis, right? It's an imaginary line which runs from the North Pole to the South Pole, something like a needle. And you also have an equator. The movement of the Earth around its axis, okay, is what is known as the rotation of the Earth. So the Earth moves around its own axis. So this axis that we see is going to make an angle of 66.5 degree with the orbital plane, right? And what is the orbital plane? It's the plane formed by the orbit. So this axis makes an angle of 66.5 degree with the orbital plane, right? Now consider this is the Earth, and because we've made Earth that big, we'll have to make Sun even a bit more big. Forgive me, this is actually not the shape of the Sun, but let's say this is the Sun. When the sun rays come, okay, they're going to come and fall on the Earth something like this. Right? Okay, let me just extend this as well. Now given that this is a sphere, what happens is that it's only half of the portion, okay, if I may divide it by this black line, the one on the right and the one on the left. By the reason that it is this part of the earth which is facing the sun, there is a daylight, okay, there is a daylight, if I may put it in, which color do you want me, yellow? So this particular portion of the earth which faces the sun has day, okay. Why? Because the sun rays are falling directly on this particular piece, right? So this part of the earth will have a day, whereas the one which is lying on the other side, which is this portion, okay, it is going to have night. So this piece is going to have night. Due to the earth's rotation around its own axis, okay, what will happen is, as the earth moves from west to east, right, this portion is gradually going to go this side, right, and then the portion where the day was not there is going to come and face the sun, and when it faces the sun, then it will have day here. So this one rotation, interestingly, is completed around the sun in 24 hours, right, and that's why we have this day which is of 24 hours. The earth takes around 24 hours to complete one rotation around its axis, and this 24-hour period is known as the earth day, right. There is one important thing. The circle, this line which we spoke about, which is this black one, which actually divides these two portions, the one which has day and the one which has light, is known as the circle of illumination, okay. So the circle basically divides the part which has day and the part which has night. Now interestingly, if you see, this does not coincide with the axis. This was the axis, right? So it does not coincide with the axis. It need not necessarily be in line with the axis of the earth. Now can you tell me what will happen if the rotation was not there? If this thing did not happen, if the earth did not move, what will happen? This portion of earth which had day will always have day, and the one which had night will always have night. So this part of the earth is always going to remain hot, and this will always remain cold. So therefore this rotation is very important.
So I hope you have learned about the rotation of the earth, its effects, then revolution of the earth and its effects. Then you have also learned about Aryabhatta and Nicholas, who were they and what did they prove, and then you have understood what is circle of illumination, and apart from the two terms aphelion and perihelion. So that's all for today. Tomorrow we'll be taking up the seasons, the part of seasons, that is solstice. So before coming to the class, just read whatever we have done so that the concept is clear, and also try to read about the seasons from your book. So that's all for today. Stay safe, stay home.